Professor Atri, let me recollect how it all went. A few weeks ago, I received a phone call from Secretary of Dean Arandi. Professor Sunoj, Dean wants to talk to you. I said, look, what is this? Dean wants to talk to me, which is unusual that Dean directly talks to a faculty member. And then Dean phone gets connected and Professor Atri tells me that, hey, congratulations. I was like, what? For what? And then he said, you have been chosen for this research dissemination award. Of course, naturally, as a human being and as a scientist, you feel good about it. And thank you, IRCC, for continuing this excellent tradition of honoring good work that is being done at IIT Bombay. I have been a fortunate recipient of Research Paper Award in the past, Research Thematic Research Theme Award in the past. Again, this is the first time I'm getting a Research Dissemination Award. So with that said, let me tell you at the outset that there is those who are planning to leave for lunch, maybe let me serve this as a soup because there are hardly any chemical structures that is going to appear. So you can stay back and relax and listen to some stories prior to lunch. So this is a story about cooperative catalysis and how we started pursuing this interesting field of cooperative catalysis. There are only 2 slides which has some chemical structures or some chemistry in it. Rest are all general. And the younger crowd would perhaps get motivated by stories because, as a teacher, I'm a storyteller, so I don't want to alter that. And this is not a serious talk wherein, I would like to talk about the finest details of our research. So I will keep it very broad and general. With that said, we work in the area of catalysis. When anyone talks about catalysis, it is all about transition state that you would see at the hilltop. For example, when you talk about a reaction, it typically goes through a transition state which is at the hilltop. So the question is, can we bring down this barrier which needs to be overcome? And we in common life, we typically use that, oh, I want to do it. I want to practice yoga. I want to go for running. But there is a barrier, there is a barrier. So you need to have a catalyst to bring down the barrier. And sometimes it may be a good friend inducing you to take part in sports activities and so on. So we need a catalyst. So many chemical transformations also require a catalyst to bring about this lowering of barrier. In general terms, I would say make the reactants more enthusiastic about participating in a reaction. So that is broadly the field that we are interested in. So we basically look at the hilltop positions of a chemical transition, that is a transition state. And the kind of work that eventually resulted in this recognition is about a field, an emerging and rapidly emerging field known as cooperative catalysis. As the word implies, there is some sort of a cooperation between catalysts. So that is precisely what we have been interested in. So in a typical work that involves cooperative catalysis, we look at energies, we look at barriers, we look at thermodynamic feasibility, and try to reconcile, try to connect with experimental observations, typically what is known as a stereoinduction or inertial selectivity. And we also use this information for predicting new catalysts. These are kind of ambitious dreams, but then one should try doing that. And there are predictions on new substrates, suggest intermediates and that an experimentalist would like to look for. In that way, we interface with experiment very often, and we have some very active and enthusiastic collaborations with many people around the world. So in cooperativity, in generic terms, you can view this as some sort of a push and pull. And if these are brought together in concert, in some sort of a resonance, some sort of synergy, then the process gets done, right? If you just try to pull an object as compared to pull and someone pushing it, then it becomes better. And that is a kind of catalysis that I'm talking about, where there is a cooperativity, and that also imply that there are minimum 2 or more catalysts involved. So these are new areas that we wanted to venture into. And initially, as with any story, then this is how the story starts. And this talk is set in the mode of a storytelling. So we thought that we should take this uncharted territory, very nice green and watery water bodies around, and we could see waterfalls, we could see cactus, very nice scenic route that we want to take, because we were fascinated by the expected complexities of these reactions. And we wanted to enjoy that path that we take, and we entered into this multi-catalytic reactions. That is where our journey started. And this journey, there are two characters, key players, which would keep appearing in every other slide. One is Gary, other one is Hemanta, or Bhaiya as we call him. This slide is not an acknowledgement, but it is about their story. Okay, let me underline, it's about their story, how these people transformed their career by working in cooperative catalysis. Okay, so that's their story. Okay, now one example, back in 2013, 2014, when we started looking at this cooperative catalysis, these are fairly complex problems and non-trivial in any stretch of imagination. So we tried to look at this chemistry and spend a lot of time. And then we started submitting this manuscript with a lot of enthusiasm, because this is the first in the world, first time counter ion is found and identified as the origin of selectivity, all like a lot of excitement. And the student involved was Gary, and Gary was like super excited about this. And we submitted this paper to Nature Communication, great reports, everything was fine. We were asked to revise, resubmit, reject. Okay, not a broad interest. Come on, like this is one of the nastiest letters I ever wrote to an editor, and because I don't plan to submit that journal anymore, so I wrote a very nasty letter. Okay, so that was the starting point. Then we went to Journal of the American Chemical Society to publish this work, and here comes a rejection in 24 hours. Not of broad interest. All right. Then editor came down to Mumbai on a ACS editor's visit, and Gary and me took him on at our poster presenting the same work, took him on to the extent that there was a lot of crowd watching this fun game of, intense scientific debate. This is probably one of the best times I had with an editor live in, real life, one-to-one. He was at the poster for about 40 minutes. We will not give up in regards to what this result stands for, and he will not give up on his decision of rejecting the paper without review. Okay, this is the test rejection. And we were arguing with him. He went back to his office, back to the US, and reactivated this, and it was reviewed again. But it was with a mission that it would be eventually rejected. He made sure the point that his first decision was correct. The paper was rejected again. And unfortunately, this turned out to be one of the most uploaded manuscripts in my career. And it would be such a disappointment for the student concerned. Most uploaded manuscript, not due to any fault with the result, but due to perceptual clash with the referees. They felt that this is not of broad interest. We always felt it is of broad interest. We always felt it is very important. And then we went on. That was the, you see the previous slide of green, and we wanted to take this path, very romantic concepts about cooperative catalysis. And this is where we started. And soon enough, we saw that no, all juice is drying off. It's very tough field. We burned our fingers. It appeared so. And dessert, everything went off. All the charm, cheer. I don't know how and where we are heading to. But we thought that we should remain persistent. And pretty much at that time, this paper was published in 2014. And I had a lecture tour to the US universities, 6 of them, East and West Coast. And I went to UC Berkeley, gave a talk there. And to my surprise, a very famous organic chemist from UC Berkeley, Professor Dean Toste, and he had read this paper, not just every line of it, every line in the supporting information as well. So we were like very fascinated. Oh, somebody in Berkeley reads our paper. And okay, so we talked for about 3-4 hours, and then decided that, hey, we should collaborate. So that is story 2.1. We started collaborating on this emerging area of cooperative multi-catalytic reactions. Story 2.2 is that the first story was to rationalize experimental observation using computations. The second story, story 2.2, is that we predicted, they did the experiments later, and that triggered a fascinating series of collaboration. We still have a couple of active projects with the same group. So that was very fascinating, even though we struggled to publish our first work in cooperative catalysis. The second and subsequent work was, all right. Okay, that was just a prank, okay, just to make sure that people are paying attention, because we are discovering how to teach online, and this prank will work with students. Like, people would unmute microphone. Oh, I'm here. Hi. Okay, so let's go ahead. This is story number 3. We made an attempt to one of these fellowships the country celebrates. I would misname it as Golden Jayanti. We made an attempt. Wrote a proposal with a lot of literature background and justifying why we should do this, pursue the study on cooperative catalysis, because it holds a lot of promise. But the committee forecasted that in the next 5 years, no, this area may not flourish much. And this is what we got, although we thought great about this cooperative catalysis. We decided to move on. We said, never mind, like Winnie the Pooh, those who remember. And we formed a greater cohesive team, and then thought, like, what will we do with that proposal we spent a lot of time on? Oh, why don't we try writing a review on it? And that is the story number 4 that resulted in this very fascinating award from IRCC. We put together our thought, published in one of the highly respected journals in the field, that is ACS Catalysis, and that was the starting point. This creative bicycle that is there, it summarizes our activity in organo and transition metal catalysis in the field of cooperative catalysis. And this is one of the pictures which I have taken from that published paper, just to tell you that one or more catalysts act in tandem, and we were interested in looking at the mechanism. And then it's time to give a progress update. Back in 2015 to 2020, in last 5 years, what have we done with cooperative catalysis? You can see, usually I'm very reluctant to flash my publications, but here there is a point because it's a story. So let me take the liberty of showing some of the papers which came out of. Is the paper ultimate objective? No, not really. But the kind of mechanistic insights that we could derive out of this computational catalysis problems were so deep that it led to a lot of new experiments. Okay, so we built foundation, we built pillars to understand where is the origin of cooperativity, how these catalysts can work together. So with that said, progress report phase 2, even more fascinating set of papers. New team got expanded, new students joined the project cooperative catalysis. I have highlighted wherever there is cooperativity in this slide, and this has been a fascinating journey, and we are marching on, solving some of the most intricate problems in cooperative catalysis. And the kind of collaborations that have resulted out of this, our activity in cooperative catalysis is the most satisfying aspect, most satisfying dimension of this cooperative catalysis activity in our group, is that a lot of people, a lot of famous experimental organic chemists want to collaborate with us in being able to understand reaction mechanism of this complicated territory of how catalysts work together, how do they talk to each other, how they can work in concert so that the reaction becomes successful, and how the catalysis can control selectivity in the product formation. And now one would say that, oh, you published some papers, you gained fame, but I must also tell you that there are about 500 plus citations to all these papers as of now. Okay, our activity in cooperative catalysis started back in 2014 with first publication, and in last 6 years, about 500 citations from all around the world. And what these people have done as of now, Garima is a faculty member at IISc, the first ever female faculty in organic chemistry department of that institute. I'm very proud of Gary, and I'm very proud of Hemanta, who is at Utkal University, used to be very shy, but now he has transformed into a good prof over there, and students talk about him. And he's on a sabbatical doing his postdoc in Israel with a famous computational chemist. And I thought, like, this kind of storytelling is what would be more appropriate for a pre-lunch lecture, and that is what I tried to do it. And before Milind tells me your time up, I'm done. Thank you very much. And I also wish to thank IIT Bombay and their exceptionally fast supercomputer, without which none of this work would have been possible. I also thank the institute and all administration, all my colleagues, all my students, all my research team members in this occasion, and thank you all.